Introduction. Most of the substances around us undergo changes. Some of these changes can be temporary, with no new substances being formed. They are called physical changes. In certain other changes, new substances are formed and the parent substance loses its identity. In such changes, we cannot get back the original substance from the new substance by simple means. They are called permanent changes. For example, burning of paper to yield carbon. When paper is burnt, black particles of carbon ash is formed. Now it is not possible to get back paper from it. This is a permanent chemical change. Objectives. At the end of this lesson, you'll be able to recognize chemical changes, write equations to represent a chemical reaction, classify chemical reactions, list examples for different types of chemical reactions. Chemical reactions. A chemical reaction is that in which a substance or substances react chemically to form a new substance or substances. The substances that take part in a chemical reaction are called reactants. The new substances which are formed are called the products. Iron plus sulfur gives iron sulfide. Iron and sulfur are the reactants and iron sulfide is the product. When sugar is heated, it gets charred. The water molecules in the sugar leaves behind carbon. Writing a chemical equation. In a chemical reaction, the reactants, one or more, react together and form a new compound known as the product. For example, aluminium oxide reacts with dilute sulfuric acid to form aluminium sulfate and water. The reaction can be written as aluminium oxide plus dilute sulfuric acid gives aluminium sulfate and water. Writing a chemical equation. The following steps are followed to write a chemical equation. Symbols and formulae of reactants are written first on the left-hand side. If there is more than one reactant, then a plus sign is placed between the different reactants. Aluminium oxide and dilute sulfuric acid, for instance, are written as Al2O3 plus H2SO4. An arrow is marked after the reactants to indicate that they react to form the product. Symbols and formulae of the compounds formed, products, are written after the arrow on the right-hand side, which indicates that these are formed. Here also a plus sign is placed between the different compounds formed. For example, Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O. Balancing the equation. The chemical equations are based on the law of conservation of mass. According to this law, mass can neither be created nor be destroyed in a chemical reaction. This will be possible only if the total number of each type of atom is the same on the reactant side as well as on the product side of the equation. Equations in which the number of atoms of different elements in the reactants are the same as the number of atoms on the product side are known as balanced equations. Balancing the equation. Al2O3 plus H2SO4 gives Al2SO4 3 plus H2O, equation 1, the above equation is an unbalanced one. There is only one atom of sulfur in the reactant side, while there is 3 atoms of sulfur in the product side. Al2O3 plus 3H2SO4 gives Al2SO4 3 plus H2O, equation 2. Now there are 6 hydrogen atoms on the reactant side and only 2 hydrogen atoms in product side. Multiply H2O molecules in the above equation by 3. Now the equation 2 becomes Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O, which is equation 3. Now in the equation 3, the oxygen atoms are 15 both in reactant and product side. So the final balanced equation is Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O.